Alrighty, welcome back to video 2, where we're going to continue with perimeters and areas of similar figures. And in this video, we are going to talk first about the areas of similar figures, and then we're going to move on to real life examples. So, ladies and gentlemen, you took some notes from the bottom of page 78, where it says that if I have two similar figures, that the ratio of the areas of these similar figures is equal to the square of the ratio of the corresponding side lengths. So, once again, we're taking a look, and we got this ratio right here. The area of the red ABC to the blue DEF, and there is a ratio, the area of one to the area of the other. And now we're taking those corresponding side lengths, AB and DE, and we're taking that, and what are we doing with it? We are squaring it. We're squaring the ratio of these corresponding side lengths. Now, why do we square? Well, when we think about the dimension of area is two-directional. It's two-directional. We either have length and width or we have base and height. Since we have two directions, we have to square the units. And so we're talking area, we are squaring our corresponding side lengths. So once again, as we do these examples, you might want to watch and listen, then pause and write it down so that you get a better understanding. Ladies and gentlemen, we're going to find the ratio of the areas. And we're going to find the ratio of the red to the blue for the area of these two similar figures. So they're telling us they're similar. That's important. Knowing that they're similar means they're the same shape, that the corresponding angles are congruent, and that the corresponding sides are proportional. So what are we going to do? We are going to go from red to blue, and I guess I left my highlighter on. We're going red to blue. And you might either want to write red to blue, or you might want to use some color if you have that. I like to also draw an arrow that says I'm going from this larger red one to the smaller one, the blue one. And I'm going to write my ratio. And the first one is red, so the side length for that is 9. They only gave us 1, so it's going to make it pretty easy. And the corresponding side length is 6. Now we're not done, because it says that when we want to write the ratio of the areas, it is equal to the ratio of the corresponding side lengths squared. And so now we have to actually do some math. And when we go 9 squared, what do we get? 81. And when we go 6 squared, what do we get? That's 36. Now, ladies and gentlemen, without mentioning any puns, we also talk about how these ratios are similar to fractions, and so some of the things that they can do are the same. And one of them is, we look at it and we say, can I simplify this ratio? And if you know your math facts, the answer to that question would be yes. Both of these are divisible by 9. So I can come over here, and 81 divided by 9, that gives me 9. And 36 divided by 9 gives me 4. And 9 over 4 is the ratio of the areas for these two similar figures. So you might want to pause now, write it all down, and then join me for example 4. Here in example 4, we're going to find the ratio of the small to the large of the area of the similar figures. So I like to draw my arrow in the direction of small to large, so it makes no difference if our ratio is small to large or large to small. When we did our previous example, the red to the blue, that was the large one to the small one, so it is what it is. It always works out when you do things correctly. So I'm going to write my ratio right here, and I'm going to say 5 is my small one, so that one goes first, that one goes on top. Whatever you start with always goes on top, and then where you end up with 9 is the large one, it's going to go on the bottom. Now, of course, we're not done, because the ratio of the areas is equal to the corresponding side lengths squared. The ratio of the corresponding side lengths squared. So we have to square this. And we're going to write, well, 5 squared is 25. And 9 squared is, once again, 81. And we ask ourselves, can I simplify 25 over 81? And the answer to that question is, no, we are done. That is the ratio of the areas for these two similar figures. So, ladies and gentlemen, now that we know that, we can put it to some real-life tests and actually do some real-life work. And we're going to find the perimeters and the areas. And it says in example 5, the ratio of the corresponding side lengths of the two similar rectangular tables is 4 to 5. Part A says the perimeter of the larger table is 44 feet. What is the perimeter of the smaller table? So what do we have to say to ourselves? Well, we know that the ratio of the corresponding side lengths is 4 to 5. So that's my first ratio. I know that the corresponding side length is 4 to 5. Now it does say perimeter. Perimeter means we are good. We don't need to do anything special with that ratio. And it says that the perimeter of the larger table is 44 feet. So now in my second ratio, where would I put that 44? Would I put it on top or would I put it on bottom? And for those of you who are answering me and talking to your screen, that's another way of participating in learning, is you would say, hey, 5 is larger than 4, so that means 5 represents the larger table, so we need to put the 44 at the bottom. Do we know what the smaller one is? No, that's what we're trying to find, so that becomes our variable. And then we do our cross products because we know that in proportions, cross products are equal, and 5 times x is 5x, and 44 times 4 is 176. So we know 5x is equal to 176. Now we take our learnings of solving equations. To isolate x, we use the inverse of multiplying by 5. We divide by 5, and of course, to keep it balanced, we have to divide both sides by 5. And we end up with x equals 35.2. And the answer is going to be feet. Those are our units. And we know that this is what? That's right, it's the perimeter of the smaller table, because that's what the question was asking us. In part B, the area of the larger table is 120 square feet. What is the area of the smaller table? Once again, they gave us the corresponding side lengths. So we're going to come down here and we're going to write 4 to 5, again, is the ratio of the corresponding side lengths. But now they're saying area, and we know that area means that we have to square those corresponding side lengths. We're going to make our proportion by saying that's equal to what? The ratio of the areas. Well, we don't know the area of the smaller one, and the smaller one is still on top. We do know the area of the large one, 120. Now, before we can get started with solving, we have to first do some math. And 4 squared is 16. 5 squared is 25. And that's equal to x over 120. Then we do our cross products. 25x. 25x is equal to, well, 16 times 120 is 1,000. Ooh, that's an x right there, by the way. 1,920. And then, of course, 25x equals 1,920. If I want to do the inverse of multiplying by 25, I divide by 25 to keep it balanced. It's both sides. So x is equal to 76.8 feet. And of course, we're talking area, so that's feet squared. And this is what? Area of smaller table. Makes sense because 76 is less than 120. All right? All right, so go ahead and write all that down and join me for our last example of the night. In example 6, it says a window is put in a door. The window and the door are similar rectangles. The door has a width of 4 feet and the window has a width of 30 inches. Part A says the area of the door is 32 square feet. What is the area of the window? So we're going to be doing the same thing we just did in our previous example. However, some of you hopefully noticed as we read that, we have an issue here because it says the door has a width of 4 feet and the window has a width of 30 inches. Well, feet to inches is not consistent, so we want to make the units the same. I can either take 4 feet and turn it into inches, or I can take 30 inches and turn it into feet. Since I like to keep smaller numbers, I know that to turn feet into inches, I have to multiply by 12. To turn inches into feet, I divide by 12. So that's what I'm going to do. I'm going to divide by 12, and I'm going to say that 30 inches is 2.5 feet. So now, the ratio of the corresponding side lengths is written for us. When I say door as 4 feet to the window is 2.5 feet. Make sense? We could have changed 4 feet into inches and we could have written that ratio that way. Or we could have put the window on top and the door on bottom. Makes no difference. And now it says the area of the door is 32 square feet. Well, we're talking area, so the first thing we have to do with this corresponding side lengths is we have to square it. And then it says of the door. Well, again, the door, we have the door on top, so we have to keep the door on top. We want to find the area of the window, so we're going to put the window on the bottom. That is our variable. Of course, we have to square first. 4 squared is 16, and 2.5 squared is 6.25, and that is equal to 32 over x. When we do our cross products, let me get my new color here. 16 times x is 16x, and 32 times 6.25 is 200. So 200 is equal to 16x. When I divide out my 16 so I can isolate my variable, and I do it to both sides to keep it balanced, x is equal to 12.5 feet. And of course this is area, so that's squared, and that is the area of the window. The last example we're going to do, the perimeter of the window is 15 feet. What is the perimeter of the door? Okay, well, we have our previous ratio, the corresponding size that we already had. The door, which was 4, to the window was 2.5. And now it says that the perimeter of the window, we hear perimeter. Hey, that's cool. We don't have to do anything to that corresponding side length ratio. We're just going to leave it 4 over 2.5. And then the window is 15. So the window goes on the bottom. We don't know the door. It goes on top. So then we do our cross products. 2.5 times x is 2.5x. And 4 times 15 is 60. And of course, when I divide 60 by 2.5, I get that x is equal to 24. And that's going to be feet. And that is the perimeter of the door. Perimeter of the door is 24 feet. Ladies and gentlemen, that ends this video. You have one quick left to do, and there's only one part to it. It says the ratio of the corresponding side lengths of two similar figures is 9 to 14. What is the ratio of the areas? Ladies and gentlemen, when you're done, go ahead and, well, you can have another stack. You can do what you want. You need to come back and join me tomorrow, and we'll answer any questions that you have. Have a great night. Thanks for joining me.